Hello everyone. Let's have a look at this particular problem here. Now you can have a look at the statement here, and I will just explain to you what is happening with the help of this figure on the right hand side. So they have got a system where we have two masses m1 and m2, and they are hanging from two light inertialess pulleys in this manner. The upper one is in fact the stepped pulley, which means that it has got two diameters. The inner one is the smaller one over which a thread has been wound, and the thread goes down, goes over the other pulley, and then goes back to the first one over the outer diameter now, and then supports a mass m2 at the other end. They have given us the values of m1, m2, and they have also given us the values of the two diameters at the top and the relation between them. One of the radii at the top is 1/3 meters, and the other one is 2 times of that, so 2/3 meters. With the help of that, we can also figure out the diameter of the lower one. That is also fine. They have given us that the friction here is sufficient so that the strings or the threads are not going to slip over the pulleys. Now that means the pulleys are going to rotate. This question has got a dynamic aspect as well as a kinematic aspect. Let us have a look at both of them one by one. We can start probably with the dynamic aspects of this question. Now the string sections, we have got 3 vertical sections. Each vertical section will have a force in it, which might be different from the tension present in the other sections. So I will have to assume 3 different values of tensions. One for the left section, one for the middle, one for the right. Let there be tensions T0, T1 and T2 as shown. So what I have done is I have started from the innermost end of the string, and in the first one which I will encounter, in the first section that I will encounter, I have assumed the value of tension to be T0. In the next one that I will encounter, T1. In the next one that I will encounter, T2. Now we know that whenever the pulleys are rotating, there is usually a different value of T on either side of the pulley. Now will that also be the case in this case? Now although the pulley is going to rotate, you will have zero moment of inertia for the pulley. So when you try to write that equation, net torque is equal to I alpha. Torque net external is equal to I alpha. You will see that even though the pulley has a value of alpha, there is no I is 0. That means the right hand side must become 0. That means the net torques must be equal to 0 on any of the massless pulleys. It doesn't matter whether they have alpha or not. When you use this idea for the lower pulley, you will get that in order to balance the torques, T1 and T0 must be equal. So we immediately get T1 is equal to T0. That's the first equation. But you will also have to balance the torques on the upper pulley. That is also going to give you a relation between T1 and T2. Now the radius of the inner step is R, while that of the outer step is eta R. So the total anti-clockwise torque on this upper pulley is eta R into T1, and for the clockwise torque I will have to find the torque due to T0, which is equal to T1, and I will have to find out the torque due to T2. So the equation is eta R T1 is equal to R T1 plus eta R T2, and that will give you eta minus 1 times T1 is equal to eta T2, or you will get the value of T2 as eta minus 1 into T1 divided by eta. This is the relation between T1 and T2 that we have got here. So this is the dynamic aspect of this. Now you can try to write the force equations for M2 and M1, and what will you get? For M2, the forces are M2g in the downward direction, T2 in the upward direction. Let us say that M2 has an acceleration A2 in the downward direction, and m1 has an acceleration of a1 in the upward direction. We will have to find a relation between a1 and a2 also, but for the time being the equation that I can write for m2 is m2g minus t2 is equal to m2a2, that's third, and for m1 the equation is t1 plus t0, which will give you 2t1 because they are equal. 2t1 minus m1g is equal to m1a1. Now here comes the other aspect of this problem, which is the kinematic aspect. Let's say that as this mass goes down, as m2 goes down, the fixed pulley at the top rotates by an angle theta. If it rotates by an angle theta, then mass m2 should go down by a distance of eta r times theta, radius of the drum on which it is fixed multiplied by theta, and the total string length on this side, on the left hand side. So if you have a look at this string length, that should ideally decrease by the same amount, eta r into theta, because that's the increase in the string length on the right hand side. So this string length decreases by eta r into theta, but there is an inner drum, and as the pulley rotates clockwise by an angle theta, some amount of string will be unwound at this place. It will open up. How much string will open up at this place? The inner drum will also rotate the same angle theta, so the amount of string that you are going to get here is r theta. That will be an increase in the length of the string here. So this red enclosed string that I have shown you here, it decreases in length by eta r theta because of an increase in eta r theta here, but it also increases by r theta because of unwounding of the string on the inner drum. So the total decrease in this length is finally only r theta, not r theta, sorry, r theta into eta minus 1 decreases by eta minus 1 into r theta, and that decrease will be half on one side and half on the other side. So therefore the distance that m1 is going to go up can now be calculated. It should be r theta into eta minus 1 divided by 2. That's the amount by which m1 is going to go up as m2 goes down. So we have got a relation between their accelerations. If I call this acceleration as a, then the acceleration of m1 becomes a into eta minus 1 by 2 eta. Right, so I will just have to insert these accelerations now in these two equations and the job is done. So how do we solve? m2g minus t2 is equal to m2g minus t2, and the value of t2 should be eta minus 1 into t1 divided by eta minus 1 into t1 divided by eta is equal to m2 times a, and 2t1 minus m1g, 2t1 minus m1g is equal to m1 times the acceleration of m1, which is a into eta minus 1 by 2 eta. Now I think after this you can solve, but I will just show you the various steps. I think one way of solving this equation will be solving the system of equations will be to multiply the top one by 2, multiply this by 2 so that the 2 will go here as a coefficient of t1, and multiply the bottom equation by eta minus 1 divided by eta, which will go as the coefficient of t1 here, and then add them up so that the t1 term will cancel out. and the terms that are remaining, 2m2g minus eta minus 1 by eta into m1g is equal to a times 2m2 plus eta minus 1 by eta minus 1 square by eta square, and there is also 2 in the denominator, into m1, all that expression. So then you just have to find the LCMs on either side and take everything on one side. So the acceleration will finally be 2 eta m2g minus eta minus 1 m1g divided by, and on the other side if you take LCM, what do you get? 4m2 eta square, 4m2 eta square plus eta minus 1 whole square times m1, and there will be a 2 eta square there in the denominator. There is a eta here in the denominator, they will cancel out, so 2 eta should be multiplied here, right? So that should be the final expression for the acceleration a. But a is this, and he's asking us the acceleration of mass m1, that means this guy. So he's asking us this term, a divided by 2 eta times eta minus 1.